The Mississippi River doesn't just disappear. It's 2,340 miles of America's circulatory system, moving everything from barges to sediment to the occasional confused kayaker. So when water levels dropped 47% in 72 hours at certain points along the river in late 2024, engineers stared at their instruments like they'd just witnessed physics taking a sick day. Because what they found shouldn't be possible with any weather pattern we understand. And it's still happening right now. Let's get something straight before conspiracy theories start flying. Rivers don't lose half their water in 3 days under normal circumstances. Rain stops, water levels drop gradually over weeks. Drought conditions. You see steady decline over months, but 47% in 72 hours. That's not a drought. That's something else entirely. And it broke every model the Army Corps of Engineers had. This started in October 2024, though the warning signs showed up earlier. Memphis reported the river at 10.8 feet below normal, but manageable. New Orleans saw similar numbers, October 18th through October 20th. Water levels at certain monitoring stations dropped so fast that automated alarms started going off. Engineers thought their equipment was malfunctioning. It wasn't. Here's what makes this impossible. The Mississippi River has a drainage basin of 1.2 million square miles. That's 31% of the entire United States. Water flowing into the Mississippi comes from 31 states and 2 Canadian provinces. It's the third largest watershed in the world. You can't drain that in 3 days. You can't even drain it in 3 weeks. The volume is too massive, the geography too complex. Unless something fundamental changed, the first explanation everyone jumped to was drought. The Midwest had been dry. Rainfall totals were down across multiple states feeding the Mississippi. But here's the problem with that theory. Drought doesn't work like flipping a switch. The river's flow rate had been stable for weeks before this, around 250,000 cubic feet per second at Vicksburg, Mississippi. That's normal for fall conditions. Then it crashed to 137,000 cubic feet per second in 3 days. For context, that's like the entire output of Niagara Falls just deciding not to show up for work. Twice. The Army Corps of Engineers mobilized teams immediately. They started checking everything. Dams, levees, tributaries, underground aquifers, anything that could explain a water loss this dramatic. What they found didn't make sense individually, but together, it painted a picture nobody wanted to see. First, the reservoirs upstream. The Mississippi has dozens of reservoirs and control structures managing water flow. The Corps checked release rates from every major dam. Nothing unusual. In fact, several dams had increased their release rates to compensate for low river levels. Water was being added to the system, not removed, yet levels kept dropping. Second, they looked at evaporation. October in the Mississippi Valley isn't exactly Death Valley in July. Temperatures were normal. Humidity was reasonable. The math didn't work. You'd need temperatures 40 degrees higher and zero humidity to get evaporation rates that extreme. Plus, evaporation is a slow process. This was rapid. Tributary analysis. The Mississippi has major tributaries. The Missouri River, the Arkansas River. These are massive waterways in their own right. Engineers checked flow rates on every significant tributary. The tributaries were flowing normally. Water was entering the Mississippi at expected rates, but it wasn't showing up downstream. That's when someone suggested the unthinkable. What if the water was going down instead of forward? The Mississippi River sits on top of one of the most complex geological formations in North America. Layers of limestone, sandstone, clay, and alluvial deposits going down thousands of feet. Normally, the river is separated from deep aquifers by relatively impermeable clay layers. But relatively impermeable isn't the same as completely sealed, particularly in areas showing the most dramatic water loss. What they found was confirmation of a theory that should have stayed theoretical. The clay layers had developed cracks, not just little cracks, fissures, channels. In some places, water was flowing through openings wide enough to drop a basketball through. The water wasn't evaporating. It wasn't being diverted. It was falling through the bottom of the river into underground aquifers hundreds of feet below. Now you might be thinking, okay, clay cracks. Sure, but not like this. Not suddenly, not across hundreds of miles of river. Something caused this, and engineers had theories. None of them comforting. Theory 1 was seismic activity. The New Madrid Fault runs right under the Mississippi River. This fault zone produced some of the most powerful earthquakes in American history back in 1811 and 1812. Earthquakes so strong they made the Mississippi River run backwards temporarily and rang church bells in Boston. The fault has been quiet for over 200 years. But quiet doesn't mean dead. Seismologists check their data. No major earthquakes. You don't need a big earthquake to create problems. Little tremors too small for people to feel, they happen constantly. The New Madrid seismic zone records thousands of them every year. Most are magnitude 2 or less. You'd never notice, but accumulated over years, those tiny tremors can create stress fractures in rock and clay, like bending a paperclip back and forth until it snaps. The clay layer under the Mississippi has been stressed by decades of micro-earthquakes. Then something, possibly a slightly larger tremor in late September 2024 that measured magnitude 3.1 near Dyersburg, Tennessee, might have been the final stress that opened up pathways. Theory 2 involves something engineers have been warning about for years: groundwater depletion. The aquifers under the Mississippi Valley have been pumped hard for decades. Agriculture, industry, municipal water supplies, everyone's pulling water out of the ground. When you remove water from an aquifer, the rock and soil structure can compact and settle. This creates voids, channels, changes in pressure. One of the major underground water sources in the region has seen water levels drop by over 50 feet since the 1980s. That's a lot of water removed. A lot of space created underground. The theory is that these depleted aquifers created a pressure differential. The river water, sitting on top of fractured clay, found pathways down into zones of lower pressure. Gravity did the rest. Off Theory 3 is the one that keeps geologists up at night. Subsidence. The entire Mississippi Delta region is sinking. Always has been. Really, the weight of sediment deposited by the river over millions of years presses down on the underlying geology. New Orleans sinks about 2 inches per year. Parts of coastal Louisiana are going down even faster. But subsidence isn't uniform. Different areas sink at different rates depending on soil composition and underground structure. What if localized subsidence created new fracture patterns in the clay layers? What if areas that were geologically stable 20 years ago are no longer stable because the ground has shifted? The Mississippi River basically sits in a giant bathtub of clay. If that bathtub develops cracks from the bottom settling unevenly, water finds a way out. The reality is probably a combination of all three theories. Microseismic activity weakened the clay structure. Depleted aquifers created pressure differentials. Subsidence opened up pathways. The perfect geological storm that nobody predicted because nobody thought to look for it. Now here's where this goes from interesting to critical. The water isn't just disappearing into a void. It's going somewhere. Specifically, it's recharging aquifers that have been depleted. Sounds good, right? Free water storage. Except it's not controlled. Nobody's managing this. Nobody knows exactly where the water is going or what it's doing when it gets there. Some of that water is ending up in drinking water aquifers, which would be great if the Mississippi River was clean. It's not. The Mississippi carries agricultural runoff, industrial discharge, urban wastewater. It's one of the most polluted rivers in America. Now you're potentially introducing that contaminated water directly into groundwater supplies that millions of people depend on. The city of Memphis gets 100% of its drinking water from underground aquifers. So, does Jackson, Mississippi, Little Rock, Arkansas pulls significant amounts from groundwater? If Mississippi River water is infiltrating these aquifers through uncontrolled pathways, the contamination risk is enormous. Nitrates from fertilizer runoff, pesticides, industrial chemicals, heavy metals, all of it potentially seeping into drinking water supplies. The EPA mobilized in November 2024 to start testing groundwater quality along the Mississippi. Early results showed elevated nitrate levels in wells that previously tested clean. Not yet at dangerous levels, but trending wrong. They've issued advisories to cities along the river to increase monitoring of their water supplies. Then there's the economic impact. The Mississippi River is a commercial superhighway. About 500 million tons of cargo moves on the river every year. Coal, grain, petroleum, chemicals, you name it, barges carry it. But barges need a minimum depth to operate. Most need at least 9 feet. When water levels drop too low, Barges can't move. Shipping stops, and the economic damage racks up fast. Dozens of barges were stranded. Shipping companies lost millions. Farmers couldn't get grain to market. Power plants ran low on coal. The Port of New Orleans, one of the busiest in America, had to restrict traffic. Economic analysts estimated the disruption cost over $2 billion in that short window. And it's not over. River levels have partially recovered since October, but they're still 20 to 25% below normal in many areas. The Corps has implemented emergency water releases from upstream reservoirs to maintain minimum navigation depths. But that's a temporary fix. You can't just keep draining reservoirs. They have their own purposes: flood control, hydroelectric power, water supply. This is robbing Peter to pay Paul. The shipping industry is adapting. Companies are loading barges lighter, so they sit higher in the water. That means more trips to move the same amount of cargo. More trips means higher costs. Those costs get passed to consumers. The price of everything that moves on the Mississippi, which is a lot, has gone up. When shipping is disrupted, grain sits in silos. Farmers lose money. This isn't theoretical. Farm bankruptcies in the Mississippi Valley increased 18% in late 2024. Not entirely because of the river situation, but it's a contributing factor. The Corps of Engineers has started emergency response projects. Dredging means scooping out sediment from the riverbed to make it deeper. It's expensive. Around $150 million for the emergency dredging operation launched in November. And it's temporary. As soon as they stop dredging, sediment fills back in. They're also exploring something more radical: sealing the leaks. The idea is to inject materials into the fractures in the clay layer to block water from escaping into underground aquifers. Sounds simple until you realize the scale. They'd need to seal potentially hundreds of miles of riverbed. The cost estimates are in the billions, and nobody's sure it would even work long-term. There's also the question of whether sealing the leaks is even the right move environmentally. Some hydrologists argue that the aquifer recharge, even if uncontrolled, might be beneficial long-term. Those aquifers have been depleted for decades. Letting them refill could restore water supplies for future generations. The contamination risk is real, but may be manageable with better monitoring and water treatment. Others argue this is a disaster in slow motion that needs to be stopped immediately. The river serves too many critical functions: navigation, flood control, ecosystems, drinking water, recreation. You can't just let it drain away and hope for the best. The economic and social costs are too high. States are blaming each other. Upstream states want downstream states to use less water. Downstream states say upstream states are taking too much. The federal government is caught in the middle, trying to coordinate between the Army Corps of Engineers, the EPA, FEMA, and about a dozen other agencies with overlapping jurisdiction. Congress held hearings in December 2024. Engineers testified. Scientists presented data. Politicians argued. Nothing concrete came out of it, except a request for more studies. Meanwhile, the river keeps dropping every time there's a dry spell. The environmental impact goes beyond water quality and economics. The Mississippi River ecosystem is collapsing in sections where water levels are critically low. Fish populations are stressed. Migratory birds that depend on river habitats are finding less food. Wetlands along the river are drying out. The ecological damage will take years to assess fully and decades to repair if it's even possible. There's also the issue of saltwater intrusion at the river's mouth. The Mississippi empties into the Gulf of Mexico near New Orleans. Normally, the river's flow keeps salt water from pushing upstream, but when river flow drops dramatically, salt water advances inland. This happened in October 2024. Salt water moved 30 miles up the river, far beyond what's normal. Salt water in a freshwater river is bad news. It kills freshwater organisms. It makes water unusable for irrigation. It corrodes infrastructure. New Orleans had to activate emergency pumps and barriers to protect the city's water supply. They built a temporary underwater sill, basically a dam on the riverbed, to block salt water. It worked, but again, temporary and expensive. Looking forward, the projections aren't great. Climate models suggest the Mississippi Valley will see more frequent droughts. That means less water in the river naturally. Combine that with the structural issues, allowing water to leak into aquifers. And you've got a compounding problem. Some models show the river's average flow rate could drop 30% by 2050. The Army Corps of Engineers is developing long-term plans. More reservoirs to capture and store water during wet periods. Better monitoring systems to detect leaks early. All of it costs money. Tens of billions of dollars. Money that has to come from somewhere, probably taxpayers. There's also discussion of fundamentally rethinking how America manages its rivers. The Mississippi has been treated as an infinite resource for 200 years. Take as much water as you want. Dump as much waste as it can handle. Build right up to the banks. That model doesn't work anymore. The river is showing us its limits. Some experts are proposing a Mississippi River Basin Authority, similar to what Tennessee did with the TVA, a single federal agency with authority to manage the entire watershed, control water allocation, enforce pollution standards, coordinate infrastructure projects. It's a massive bureaucratic undertaking that would face political opposition from states who don't want to give up control. But something has to change. The October 2024 crisis was a warning shot. The river's telling us the system is breaking. Whether we listen or wait for a bigger crisis is up to us. Right now, as of January 2025, the river is holding steady at about 15% below normal levels. Better than October, but still concerning. The Corps is monitoring those underground leaks constantly. They've installed sensors along hundreds of miles of riverbed measuring water flow and pressure. The data shows continued leakage, though at reduced rates compared to the peak crisis. Engineers have identified 17 major leak zones and over 100 minor ones. The major zones are losing an estimated 50,000 cubic feet of water per second combined. That's 375,000 gallons of water every second just vanishing underground. Over a day, that's 32 billion gallons, nearly 12 trillion gallons. To put that in perspective, that's more than the entire annual water consumption of New York City, Los Angeles, and Chicago combined. The water that's leaking away isn't coming back to the river. It's gone into the aquifer system, and aquifers release water slowly. It could take decades for that water to return to the surface through springs or wells. In the meantime, the river operates with less water than it should have. The Mississippi River has survived ice ages, droughts, floods, and 2 centuries of human interference. It's resilient, but resilience has limits. What engineers found when the river lost 47% of its water in 3 days was that we're pushing against those limits. The geology under the river, stressed by earthquakes, depleted by overpumping, settling from subsidence, it's changing in ways we're only beginning to understand. This isn't the end of the Mississippi River, but it might be the end of the Mississippi River as we've known it. The stable, reliable waterway that built American commerce and agriculture. That river might be becoming something different, something more unpredictable, more difficult to manage, more expensive to maintain. And the scary part? If it can happen to the Mississippi, it can happen to other major rivers. The Colorado, the Rio Grande, the Missouri. They're all sitting on complex geology, all stressed by climate change and overuse. The Mississippi was just first to show cracks, literally. Thanks for watching. Subscribe for more coverage as this situation develops because it's far from over.